Okay, so far this week we started to talk about how to calculate specific heat capacity. And what we're going to do today is we're going to break down the how in terms of how to work through these problems. So what we're going to do is we're going to work together on question number 1. And the question says, a 15.75 gram piece of iron absorbs 1086.75 joules of heat energy, and its temperature changes from 25 degrees Celsius to 175 degrees Celsius. Calculate the specific heat capacity of iron. So if you pay attention today on this stuff that we're going to be doing together, you're going to have the answer for number 1. So make sure you follow along with me, all right? So there's a couple things that we need to be able to identify. First and foremost is we need to know that C equals specific heat. So for those of you that are taking notes, C equals specific heat. And that's what we're going to be measuring right here. So what we need to be able to unravel now is our moving parts, okay? So we are going to be finding our mass, our heat, our initial heat, and our final heat, okay? And that's going to be C. Okay. So now that you have this stuff written down right here, you should be able to start to break down the problem. So we're going to start off with the M, which in this case is going to stand for mass. And just like how in the beginning of the question, it says 15.75 grams of a piece of iron, that's what we're working with. So we're going to write, for M, we're going to write 15.75 grams. Okay, so you should have that written down there. So the next thing we need to find is heat. Remember, Q stands for heat. You should remember that from when we were talking about changes in internal energy. So our heat in this situation, just like the question says, is the 1086.75. Okay, oh, sorry, joules. So you should have that written down. So now we need to find our temperature initial and our temperature final, okay? Now this is important that you don't mix these up. Our delta T, remember delta just means change in. Delta T is always going to equal our T final minus T initial. Okay, so just kind of work with me here. So that right here, our delta T, or our change in temperature, is always going to be written like this: T final minus T initial. So it's important that we know those two things, and you never want to mix those up because then obviously your answer is not going to be correct. Okay. So our initial temperature here was the 25 degrees Celsius. And then we ended with 175 degrees Celsius, okay? So now we have our T initial and our T final, and that's all that means, the TI and the TF. Now what we have to do with that is we actually have to put those together now, because just like how we written over here, our T final minus T initial. So we're gonna go ahead and subtract those two values, and that's gonna give us an overall temperature of, 150 degrees Celsius, okay? So we have all the pieces that we need to be able to answer this question. The only thing that we don't have now is our specific heat, which we're getting ready to measure in just a second using the equation I'm going to show you here. So for those of you that are taking notes, which I encourage all of you to be taking notes right now, go ahead and pause the video if you need to write this stuff down. Because we're going to go ahead and move forward here to see if we can get the rest of this stuff answered. Okay. So what we're going to go ahead and do is we're going to go ahead and measure our specific heat. And the way that we're going to do that is we're going to write it out like this. That is going to be the equation that we're going to be following to find our specific heat capacity of iron. So all we're going to do is go ahead and plug in for those numbers. And what that's going to look like is this. So if you would have followed the equation, you should have gotten this value right here as the 0.46 joules per gram degree Celsius. So, just like how we did before, way back when with balancing chemical equations, there's no like terms that cancel out, so everything kind of gets transferred over. So we end with joules per gram degree Celsius. So the specific heat capacity of iron in this situation would be 0.46 joules per gram degree Celsius. So if you follow the equation that you should have written down before to find specific heat, you know how to do question number 1. So make sure that you follow along with that. In terms of where we're going as we move further into this unit, we are going to be looking at some more complex versions of kind of the same deal, but it's all going to be following this kind of framework. So make sure that you take some time to practice on this, especially with question number 2 that you'll be answering on today's follow-up assignment. But it's important that we know this stuff because specific heat capacity tells us how much energy is needed to either raise or lower the temperature of any given object, which is important in chemistry, obviously, because that could lead to really cool reactions or horrible devastation. So make sure that you take the time to study this stuff and log into the video Q&A from 9 to 11 a.m. if you guys have any questions, or obviously you can just email me. All right, have a great day.